Hello friends, welcome back to my Python series. This is day 2 and it contains 3 parts. But today I will be covering part 1 and part 2, and in the next day we will see the part 3. On the right hand side I have got one image where I have jotted few important key points that would be a revision of my day 1 as well. So in Day-2 part 1 I have got something called dictionary. So let me open this, and here is the code that what you see right over here. Well, what dictionary is all about? Let's try to understand right from the diagram. Look over here, I have got a curly brace and I have got key and value, but what we find over here is the key are all string type and the value can be heterogeneous. Swaroop 99 5.7. Great. Let me print the output. So as I do that, you will see the output entirely. So what is this going to result? Well, it will be printing the entire dictionary as expected. So I got the key value, and key value respectively. What about this one? Well, you can straightforward understand that I'm targeting a particular key. So within third bracket I'm writing the name of the key whose value I want to print, and the value comes over here. The similar kind of thing I can achieve using the get function. So here also I would mentioning the key name and I would get the value back. So can I say that these two approaches are kind of indexing? Well, I can, but just keep it in mind we are not using any numbers over here, rather we are mentioning the respective keys. Hence I can say that in case of dictionary I can use indexing in the form of keys. Okay, now quite naturally there would be multiple keys, and for that reason dictionary provided us a special function called keys. So here you can see a list which would show you all the key names that the dictionary holds. So look over here, it is in third bracket, so that's a list that represents all the key names. Similarly, I have also got a function called values which would be providing me look over here how the values is coming. It's also the kind of list, right? So just like the keys, the value is also going to be in the form of a list, and it would just pinpoint the respective values associated with the keys. Now what if we want to go as a combination both between keys and values, and for that reason we have got something called items. But wait, take a note, here you are getting the data in the form of a list, but within the list you are getting tuples. Really awesome, isn't it? Again, here we have got a list, so the entirely is going to be a list, but within the list you have got tuples. So the tuples consisting of key and a value, key and a value, key and a value. So this can be quite handy at time, because if you iterate over here you would be getting the specific tuples, isn't it? Good. Now what I can do is I can perform editing. As you can see, initially the name key was having my first name, but I can perform editing, and I have done right over here, that is Swaroop got changed into Swaroop Saha, and then finally when I print I will be seeing the edited list right over here. So this is my edited value for the given key. So what are the summary can we draw from this? So I can say that I can perform indexing in the form of keys, I can perform indexing in the form of get functions, I can get a list of keys, I can get a list of values. Not only that, I can also go for tuples that consisting of both keys and values together in the form of items. I can perform modification of my existing value, and not only that, I can insert a new key as well. Look over here, the email was not there initially, but I can insert that as well. Well, I didn't do that, So why not I give a try over here. So let me write this, my Dict and email, and I wrote this. Okay, so this is something what I did, and over here I'm going to print. But I don't want to delete anything right now. Yeah, fine, no issue. I can even go for delete as well. So that means it is totally going to perform mutability. So let's run the code and let's see in action. Okay, let me clear the screen first so that it is much neat and clean. Here it comes. So I added a new field, a new key by the email, and later on I did edit that one. I delete that one, so it is going to remove the key from my existing dictionary. Hence I can summarize it in this fashion that in context to dictionary it is purely mutable in form. You can insert, you can append, you can extract, you can do search using the indexing. Everything is possible. So that's the reason dictionary would play a very crucial role in the upcoming days. Okay, so that's all from the part of dictionary. Now let's move to something called set. Let me remove this. Let's come over here. Let me open this. So set is much smaller in context to dictionary, the functionalities. So let me tell you what we can do over here, and you have to be very careful about set, because many times this confusion takes place. Well, I have got one set over here, where set is also heterogeneous. So I have got my name, I have got my age, and I have got my height. So I can simply print my set, right? And then what I can do, well, I can add a new value within the set. That means if I print now, what I will be getting at, well, let me comment this portion. So if I print now, I will be getting both Swaroop as well as swaroop@gmail.com along with 99 and 57. Look at the output very minutely. Initially my output was like this, right? 99, 5.7 and Swaroop. That the output came, and then I added a new data inside my set, and then I printed it, isn't it? But do you notice something very, very different? What is that? Well, the order in which I inserted within my set, is the order been maintained when we are displaying it? No. Look over here. I inserted the data first, my name, then my age, and then my height. But when I printed, I just saw the age came first, followed by my name, and then the height. And then when I went for editing, I added a new field. I shouldn't use the word editing. Yeah, you can. If you think it from the perspective of the complete set, then you can say you are editing the set. But I'm not editing any value. Okay, can I do that? I will get to that just in a few minutes. So I just added one new field, and then I printed, and then see the new field came first and then the previous ones. So the insertion order is not actually maintained, and this is why happening. Reason is a set does not have indexing. I repeat, a set does not have indexing, and that's the reason why you will just see the output randomly been shown each time you run the code. There's no assurance that you will be getting the same output next time. Okay, oh, look over here, the way it appeared over here, we are not seeing the same fashion again. That's what I said. Look over here, the same thing happened. So each time you run, since there is no indexing, that's the reason the output won't be same all the time. Okay, well, I can even go for removing an item from the list. So let me do that. I'm removing my age, and after that let me print it, and the output will not have my age anymore any farther over here. Got it? So from here, what conclusion can we draw? Well, firstly, set is, first of all, I have not given a duplicate value over here. What if I would have given another 99 over here? Do you expect to see the 99 twice? The answer is no, you won't be seeing it. It will be just only one time. So first of all, set is completely unique. Okay, that's the first important thing. Mathematically, set is always going to have a unique value. Second thing is that I can add new item to my existing set. Similarly, I can remove an item from my existing set. Please take a note. I can add a new entry, I can remove an existing entry. But what would the most important point is I cannot perform any editing on the existing value. I repeat, I cannot perform any editing in the existing value. Okay, so for that reason I have written over here like this way: set is mutable. Well, set is mutable as long as you're performing add or remove operations are possible. Up to this level, set is mutable. But why set is not totally mutable is you cannot perform modification of the existing item. So we cannot convert the set. Well, I mean, since we cannot perform editing, so is there still a necessity that you have to bring some changes in a particular record present in the set? What you can do is that you can typecast the set to a list, and that's the reason I wrote like this way. But we can convert a set to a list and vice versa, because once I convert the set into a list, I will be getting indexing. Okay, the list I have done on day 1. See over here, I did that. If you want to get over it, just see the previous day's video. So that what I can do it, I can typecast my set into a list, and then I perform a search operation, and then I edit the value, and then I convert the list back to the set. That I can do it. Okay, so that's a little bit of like time consuming process, I do understand, but and that's the way you can do it. But at the end of the day, keep it in mind, you can add new entry to a existing set, you can modify entry from existing set, but you cannot perform updation. So that's the reason a set is like partially mutable. Okay, that's something which you should keep in mind. Now that's what we have to cover in day 2. I'm covering in day 2, but I want to do a little bit of recap, so that some important thing I would like to put forward. So let's get back to day 1 once again, and let me open the tuple underscore homo file. So over here I have written a couple of important things, like oh, this is homo, I want to go for hetero, this would be good enough. So here I mentioned that in context to tuples you can go for indexing. So set was preventing indexing, there is no indexing in context to set, but as of tuple is concerned, set has got no indexing, but tuple has indexing. So that's the reason in the last day also I showed you the forward direction indexing, the reverse direction, the slicing. Well, these are the slicings. Everything can be possible in context to a tuple. So remember, in context to set we cannot do anything in context to indexing, neither forward nor backward nor slicing. But there's a very big but is there. What is that? Well, at least set was partially mutable. It added new data, it removed new data. But in context to tuple, that also you can't do. So tuple you cannot go for addition, a tuple you cannot go for removing, neither you can edit an existing value. So it is completely immutable. Okay, so keep this thing in mind in context to set and tuple. These are very important feature. The set has got partial mutability in the form of adding new items, removing existing items, but we cannot do editing in case of set. But tuple is purely mutable, I mean immutable. You cannot add any entry, nor can you delete any entry, neither can you edit any of the existing entry. The only difference that is got is that tuple has got indexing, which is not there in context to set. So please keep this thing in mind. Okay, so that is something in context to tuple. And one more revision I would like to do in context to list. So let's open the list. Now this is the last thing, that's the reason I have kept it, because there is a similarity between list with that of dictionary. What is that? Well, in context to dictionary we were doing indexing in regard to the keys. So I have written like this way: my dict within third bracket name. So the name is the key, and that's how I'm doing indexing. But in context to list I don't have any keys over here, so for that reason the indexing in context to list is actually done with the help of numbers. So keep this point in your mind, that if you are going for dictionary you will be doing indexing in context to keys, and in context to list I will be doing the indexing in context to numbers, and the number starts from 0. All these things I have stated even last day also. So since you have got indexing, so for that reason you can do slicing, you can do even the modification. So list is going to modify the data. See, initially at the 0 index I have got the value as Swaroop, I change it to Swaroop Saha. So that's the modification I did. I want to remove a number. Okay, this is something very interesting. Now how do you remove it? So when we remove an item from the list, I have got two options. You can remove the item from the list in regard to the value. So for that reason, remove function will work. That is going to remove the data in context of the value. So you take the input from the user, the value that the user wants to delete, boom, the item won't be there anymore in case if it is present. Or else you can do one more thing. You can remove in context indexing. So here in the case of pop, you will mention the index number, and that's how it will simply delete. So if this is my existing list, and if I give the index as 1, the 99, this value is going to be deleted. Henceforth, we have summarized the entire thing in this particular diagram, in this particular image. So thoroughly go through this diagram, and I'm very sure you will understand these things much better way, because these are some important things that always comes up, and it creates a lot of bottleneck for the students. Well, this is the part 1, part 2 of day 2. In my next part, I will be talking about memory management, and this is really very interesting. A lot of important questions comes up with the memory management, because Python has got its own way of implementing these data structures in the memory, and that's what we will be covering in next video. Okay, until then, have a nice time. Bye bye.